We're continuing in this pre-algebra, and it's just right here. There you go. So we're on lecture 16. Lecture 16. So we're still doing algebra-based things, right? However, the difference is that you're going to see, what are you going to see? You're going to see practice with solving equations like we did last Monday right here. More complicated ones. Where'd it go? Wait, this is the wrong class. Let me move the note to the correct class. 305, which is this one. There you go. The two examples I made on my head, right? I just made the equations more complex. And when you see the homework problems, they're not going to be this complex. And I might throw in a problem here or there that's a little bit complex, but I won't go crazy, of course, right? And anything hard, we will always do it in class like this where I can walk you through it. And then the homework will reflect that. You know, it won't be crazy hard or like that. Doing chapter 2 now. Now we're in the still, and there's a couple of things that I wanted to go over because they're things that you've seen before, but you may have not seen them in a while or whatever the case might be. And it's better that we address it instead of assume that, oh yeah, you've seen this before, you're good to go, that type of ordeal. So let me show you what I'm talking about. And just log on to my computer right here. And where's the preview? Preview, here we go. That's pre-algebra textbook. We are done with that. So we're going to go open recent. And we're going to pull up the algebra textbook. And then I think I had a student, whether it was this section or the next section, where they said, hey, I've been doing the homework and it's been a little bit off. Well, there's the link on the Google Doc website or page or however you want to think of it. That has a more recent version or iteration of it. So watch out for that. And that's the only thing you want to watch out for. All right. So I'm going to jump to, so from the last two problems, right, we did section 1 and 2.2, right? And we'll do one more example like that for today. And this one I'll pull from the textbook so you can see exactly how quote unquote complicated it is. It really isn't. So they'll give you something. Let's find the quote unquote hardest problem here. They'll give you something like this. Let's do the q because q is easier to see. So negative 4q minus 2 minus 8 equals 4. So you can see it's super baby, quote unquote, compared to the problems that we did on Monday. And even if you look at the homework itself, I'm looking on page 223. So I'll write here on the right side, homework. I'll call it future homework. I'm not assigning anything yet because you should be practicing stuff for the first midterm. So future homework, page, what is this, 223. If you look there, right, you can see that the problems don't get that difficult, right? Maybe the translation problems because you have to do word problems and stuff like that. But let me do this really quick. This 4q plus 8. And everything else drops the same because changes here. That distribution was the only thing you have. You can see right here that these 8s, they cancel immediately. You just want to simplify on either side before you move things to the other side. So you notice how I could have added 8 and then subtracted 8 from the left, and then I can put it on the right. But there's no need for that, right? You can simplify or combine like terms where you can, and then when you're at this stage right here in the light blue, right, you can see that now you can divide both sides in this case by the -4. Moral of the story, don't jump the gun. Always try to simplify first. So here, this example, q equals, what is that, -6. 24 divided by 4 is -4, that's -6, yeah. So that's good there, right? Obviously, what I did in class was way more complicated than it needs to be. And even then, when you go, oh, you have variables on both sides, philosophy as well. And that's, again, similar to what you saw on Monday. So let me do a problem that is quote unquote difficult from the textbook. So this is section 2.1, 2.2, right? So this is the whole add, multiply, divide, right? And so there's that. And the other thing is that now moving on to section 2.3, so I'm giving you a subdivision in terms of how things are working. So this is section 3. Let me grab the quote-unquote hardest example that you can see here so you can have an idea of what's going on. So the hardest one I see fraction and decimal. So this one has to do with, I'll even write it here, more solving so then what happens is that you got example 2. I'm gonna scroll up just a little bit right there, and you can see something like, where's the problem? There you go. They'll tell you to solve 6 equals 1 over 4x minus 2. So this is really important because you won't see a ton of these. However, it has to do with that whole clear the fractions I was talking about. Now, last time I made the mistake of saying that there was 2 types of strategies, and it wasn't obvious because of how complicated the fraction was. So therefore, it was, okay, well, I did this, but then what happened exactly, right? It was, you were thinking, okay, cool, I did this and I did that. And then what happened was you found that I only had one type of solution, if you will, if that makes sense, that is. Okay, and then what happens is that, gosh, how should I say? it seemed like there was only one way to solve. But here, there is clearly two ways to solve here. So I'll show you right now. So here, the one way to solve. So I'm going to do the first one in purple. So it's going to be all purple. This is what the textbook does, right? It's not necessarily the best, but again, I'm going to show it to you anyway. And I'll show you the way that I find it easier, okay? And it's easier because it is, how should I say? It is, there's less fractions involved. In fact, there's no fractions involved, okay? So here we go. So first way is traditional. Put that in quotation marks. But it's also the book as well. Okay, so they say, oh, notice that 1/4 is less than 5/4. In fact, someone actually suggested this on Monday. They said, hey, you can combine the fractions. And I go, well, you could, but it's harder. This is an easy one where you can see that the fractions are easy to subtract. Well, common denominator with anything, right? So you your line and use the light green to cancel. So again, the purple on top here is to show you which fraction was going to subtract which one, okay? So then going back to purple again, what's 5/4 minus 1/4? Well, that's just 4/4. And again, black plus 6 equals -2. So I dropped everything down, as you can see here, right? Down, draw a little arrow. Okay, and then what's 4/4? Well, 4/4 simplifies to, not a trick question.
1.
It's 1, right? So you got in purple here, x plus 6 equals -2. You subtract 6 on both sides. And then these cancel, and use the light green to cancel here. And then in purple again, we got x equals -8. And you can always check the answer by replugging it in. That didn't seem too bad, right? Maybe because the common denominators were there, maybe because it was easy numbers, whatever the case might be. But let me read this problem a little bit now with so 2, this is what I call clear the fractions, right? Fractions. Okay, multiply the denominator. Okay, so what do? I'm going to rewrite the problem one more time. So if you didn't finish writing on top, that's okay. You're going to see this later in your notes. So again, the problem was 5/4x plus 6 equals 1/4x minus 2. So the way I said it last time was, hey, what do you need to multiply by to get rid of fractions, right? If you had to multiply by something, what would it be so that all the fractions would disappear? And this one, it would be 4. I hope everyone sees that. Why 4? Because there is a, I'm going to circle this in light green. There's a 4 here and a 4 here. And those guys, if you multiply by 4, the denominators would disappear. But remember, we're in equality right here. Equality. So you just by 4 with every term, right? So one way people do it is that they do parentheses this. They write a 4 like this. So it just looks like a big distribution. It also allows it where you don't miss a term. So you see here that you have to distribute this way and this way. You have to distribute this way. So obviously I showed you this on Monday very briefly, and a lot of you were like, oh, I mean, you didn't say it, but I could tell that a lot of it was new for you. Now that I presented this way, where you can see the parentheses like this, does anybody remember seeing anything like this previously in their education? Anybody at all?
I do.
Okay, good. Okay, cool. So as long as it was one of you, you know I'm not making it up, and it's actually a legitimate thing. And yes, one might argue that, hey, but the numbers are going to be bigger, professor. Look at it. The numbers end up being 5x, because the 4's cancel, plus 24 equals just a single x, right? 1/4 x times 4 minus 8. So you might argue, oh, but the numbers are bigger. That kind of sucks. And it does. But you forget that, remember, we can use calculators here. So now you just have to ask yourself, what is more worth to you, right? Do you want to mess with the fractions? Or do you want to clear the fractions as such? Then everything else is the same. So you subtract x, you subtract 24, subtract 24. So doing everything in one step, as you can see, the x is canceled, the 24 cancel. On the left side, you're left with 4x. On the right hand side, you're left with negative 32. And then as you can see, lo and behold, you divide 4 on both sides, and you also get x is equal to negative 8. Two strategies. All right. I mean, I know I just wrapped it up right now, but between those two strategies, what questions do you have? And I guess a better question to ask as well is, what parts didn't make sense, if any? All right. Sorry, someone got locked out of the class. I just saw my email right now. All right. So that was section 2.3, and here's another one where we can do a decimal right now so that people can just see a different version of it. I think that might be the hardest one as well. Yeah, we got fractions and then we got decimals. So let's do example 3. You can see that the examples themselves are complicated, but there's no decimals. Decimals I normally stay away with because they're easier, right? Honestly they're easier. They're some of the easiest, except for whole numbers, regular whole or integers, right? Positive or negative numbers and stuff like that. So when you have a problem like this, sure, you might go, hey, what's going on here and all that fun stuff, but you just do the same thing, right? Use maybe this time. You're going to subtract 5.4x from both sides. And then you can see right here, I'm going to go in green. You're going to cancel that. And then everything else stays the same. You're left with 4. Equal sign. And then you got to do this, right? Sometimes they're easy where you can just subtract this. Sometimes you can use your calculator. So it's just whatever is easiest for everyone. This one I'm going to subtract with my head because you can actually see it, right? This is just a 4 next to the x's, and 7 minus 5 is 2. And again, plus 4. Then you got to subtract the regular whole numbers on both sides. See right here that the 4's cancel, you're left with 2.4 equals negative 8, 9, 10, 11, 12. Right, and then you can do this with a calculator. Actually, you can do this in your head too, but do it with a calculator. So divide by 2.4, divide by 2.4. So this shows us that x is equal to negative 12 divided by 2.4. This is going to be negative 5, right? Hopefully people see caliber or the difference of when I'm making it a really hard problem versus a problem that I kind of go, oh, okay, well, here's something, and then you can see that there's a clear difference right there. All right. So that's section 2.3 when the book, they call it, oh, here's some harder problems where you have to worry about multiplying on both sides, or you have to have variables on both sides, or numbers on both sides, or whatever the case might be. And then what happens is that there's another section, 2.4, where they talk about finding a strategy, right? Well, you already know the strategy. You know to go through order of operations first, right? And let me see if there's a unique problem that might be interesting here. Okay, I see. They just make the problems longer. So let me show you one right now. Section 2.4. Did I underline them last time? No, I didn't. So section 2.4, in parentheses, I'll call them longer algebra. Longer algebra solving. So this is a textbook I'm going to pull because it's a good one. So you can see right here. Here's example 4. We have 10. 3 minus 8. 2s. You know what, let me change that s because that's a ugly variable to do it. Let's do 2, what's an easier variable to see? I'm going to do 2m equals 1540 minus 5. So let me make sure I copy this right. 10, 3, negative 8, 2m minus 5 equals 1540 minus 5. Okay, so this is the idea where they talk about implementing a strategy. But you really don't need a strategy, right? You just kind of just go with it in terms of order of operations. So there should be no surprise in terms of, hey, what do I do? What's going on? You know, those type of things. So when you see this, right, what's the first thing, and anyone can share this, that comes to mind that you think you should do? What's the first step?
You solve the first parentheses inside, if that makes sense. So
now, when oh, I interrupted you. Go ahead. Sorry.
No, sorry. The negative 8 and the 2m minus 5.
Right. So it depends on how savvy all of you are in terms of, how should I say, in terms of, what do you call it? In terms of how savvy you are, if you can balance multiple actions when you're doing a problem this large. Some people will say like, oh, you should do only one step at a time. And some people will go, you can do whatever you want as long as you can keep track of everything. So it really depends on you as a person. So let's use a different color now. I'm gonna use purple again. So the first suggestion was this, and I think that's good. And then if you are inclined to, you could also do this at a time. Why is that? The reason is the right side of the equal sign, it's isolated, right? There's no more going on there other than that distribution. There's no extra simplification, there's no extra plus sign, there's no extra minus sign, there's no extra fraction, there's nothing extra about it. So even though it might go against the grain in terms of people teaching, in terms of, oh, you should do one step at a time, I'm saying that if you're confident that you can keep in your head or you're doing your scratch work, hey, this is the left side, this is the right side, you should be fine, right? But for all intensive purposes for the class, I'm just going to go one step at a time so people could see line by line, okay? So yes, I would distribute that -8 first because it's the most complicated. So this implies we have now 10 bracket 3. Remember that -8 comes with it, right? Do not forget that -8. That comes as well. So that's -8 times 2m, which is -16m. Make sure I did that right. 8 times 2 is 16. Yep, negative and m. Now it's -8 times -5, so that's actually 40. And then again, I'm just going to leave the right side alone, just so that people get too bogged down by me doing too many things at the same time. I'm going to scroll up now. And then what will happen is we do inside the parentheses, right? I mean, I guess I could have asked, like, what do we do next? But it's kind of obvious, right? Inside these brackets. By the way, the brackets and the parentheses, I may have said this before, they don't have any real quote-unquote difference in the sense that they have the same priority. You always want to work from the inner to outer, but the moment you have the brackets there, don't use it on your calculator or the brackets themselves. You can just use regular parentheses if you happen to be punching this on a calculator. So no worries about that. Now what's the next step? The next step is, of course, taking care of what's inside here. So I'm going to switch to a different color here. So this becomes now -16m plus 43 inside here. And then you're left with 10 equals 15, 40 minus. Now this looks like the last problem that I did. Maybe it was example 2, I believe. Yeah, no. Yes. It's like example 2, but method 2 with the light blue here, clearing the fractions. Notice how I multiplied or I distributed the same number on both sides. Well, it kind of looks like that here, right? If you look at this point right below that green line, you'll see that it's a distribution on both sides, and that's it. By the way, I forgot the m there. Don't forget the m. Okay. So there's that, and then what? And then you distribute. So let's use another color. So this becomes negative. This becomes a positive 430. Okay, I'm going to distribute on this side now. 15 times 40, I can't do that in my head, so I'll do it on my calculator. 15 times 40, that's 600. And then you distribute one more time. 15 times 5, -5 in this case, so that's -75m, then Mike. And then now, of course, it's problem. You can put the variable on the left side, so I'll say a note here. Most teachers encourage variable number. What do I mean by that? Or maybe you already didn't know what I mean. Number right. That means that when you're finishing the problem and you're at the pretty much the last step and you have a choice of where to put the variable and where to put the constants or the numbers in this case, they tell you to put, hey, put your x on the left equals some kind of what they mean. But in reality, it doesn't matter what the hell the damn side is, right? It's just that students, when they're facing algebra for the very, very first time at a young mind, it's kind of like, what the hell do I do? So it depends on what you want to do. If you don't want a negative number with a variable, you add 160 to the right side. I hope people see that. If you are the type of person that goes, no, I want to stick to the whole move the number appropriately to the right side and keep my variables on the left side so that it's easy for me to go, oh, it's x equals whatever, in this case m, right? M equals whatever, z equals whatever, y equals whatever, you know, that type of thing. So it really doesn't matter. So it's kind of like, how you do. So I personally like to just keep the variable positive because I know I'm going to have to divide by it. So I'm going to add 160 to both sides. And you'll see right now, you're left with 430 equals 600. And then you just have to do 160 minus 75, which is 85m. Now, your answer is going to be negative, but see how, okay, maybe it's just me, but see how it's easier once you do this subtraction, right? 430 minus 600. So yes, there's still a negative answer here. But the cool, okay, not very cool, but the convenient thing is that you notice how when you divide by 85, there's not going to be a negative that students could forget when they finish the problem, right? Very last step, and say, don't write this down, say the negative was actually on this side instead, and it was positive 170, and students easily can divide by -5 because they're in a rush, they're nervous, or whatever the case might be. Whereas when you're looking at it, where the -170 was there, when you divide by 85, you know to divide only by 85. I don't know if that helps you or not, but something to consider. Otherwise, you can stick to the note that I wrote, keeping the variable on the left side. Again, it's just personal preference.
Your audio is cutting out.
I'm sorry, say that again?
Audio keeps cutting out. I don't know if it's just me.
Is my audio really bad with anyone else?
Yeah, kind of cut out a lot for me.
Okay, hold on a second. Let me see if I can do this.
It keeps cutting out.
It's still a little wonky.
A little bit. Like a few seconds ago it was.
Okay. Well, I put on Bluetooth headphones now, so we'll see how this is. Give it about a minute, and if it's too much, let me know, and then I have to just quit the WebEx and then relaunch it again. So hang tight, and thank you for letting me know. Like these type of things, let me know immediately so that you know what to do. I know what to do, I'm sorry, so that we can fix it. We don't want to hinder your education as it is already with whole remote learning. So you divide both sides by 85, and then what? And then m just equals -2. And of course, you can check your answer by plugging it back in. But you can see that it's a very long problem if you will. Notice how it's lengthy, sorry. It's lengthy, but there's nothing complicated about it versus the two problems I showed you Monday where they were semi-medium length, but there are a lot of concepts to have to recall, right? So that's pretty much the hardest it gets. And then there's other examples on the homework section or the, how should I say, the practice problems that say whatever they say. Now, there are some caveats that you have to worry about, and I'm going to show you some of them. We don't have to go through the entire formality of it, but basically there is what do you call it? The textbook goes into it saying that there's something called a conditional equation, an identity, and a contradiction. No one's ever actually described it like that when I was learning algebra the first time, as well as no one's described it like that when teaching algebra for the first time. But once you see it, you'll know what's going on, okay? So let's find a question that isn't too long so you can see what's going on. The problem is that all these questions are long so that they look confusing on purpose. You know what? Yeah, let me actually do this. Are we still on section 2.5 or 2.4 now? We're on 2.4. Okay, yeah, you know what? Let me write this down so that at least you have it in your notes. So definition. Okay, a conditional equation when an equation can be single number. In mathematics, they call that a unique solution, right? And if you think about it in terms of what the word unique means, when you look at m equals -2 from the previous example, that's unique, or a unique answer, because there is no other answer that can give you that answer. Does that make sense? I kind of said that with the word answer a lot, but the point is that when you look at this solution, the original one right here at example 4, 10 bracket 3 minus 8 parentheses 2m minus 5 equals 15 parentheses 40 minus 5m. And the question is basically, what number can you plug in to make this equal on both sides or balanced, right? If you think chemistry. Well, the answer is that it's -2, but in the bigger scheme of things, what you're trying to accomplish is to say, oh, there is only a single answer that will make this equation true. And that's what that's saying, / asking / doing, or whatever you want to call it, okay? So that's that. Now, they talk about two other things, right? They call, and I'm just going to write it down, the definition, copying the textbook, so that you can see it. And then what will happen is that once we run into them, I'll point it out. Otherwise, when you just read this, it may not make sense. But also, an equation, let me just, no, I'll type it out, yeah. Equation that true any value of the variable called identity. The solution of an identity. Oh, again, we'll talk about this, but just hang tight. And then the last one is contradiction. Equation that is all for all values. It's called contradiction. A contradiction has no solution. So let me give you a minute to type that out. Everyone has this written down? Is my audio still consistent at least?
Yeah.
All right, cool. Discourse. All right. So what do we mean by these things, okay? So it's like this. Again, these examples are straight from the book, so if they're a little bit long, don't worry about it. So, oh good, here's a short question. So, say you had this example right here, example 5. So, in essence, a conditional equation is when an equation can be solved for a single number or unique solution, right? That's basically any equation. That's how you want to think of it. And then the other way to think about it is it's like any equation that you can solve for and you can do the problem and there aren't any issues, okay? So what does it look like? Well, let me show you a baby example. So here's example 5. There's no reason to perform there's no reason to show like a really long-winded example just to show the result when you don't have to. It's more about being aware of the concept, okay? So they give an equation like this. Where is it? 7. Nope, that's not it. It's this one right here. So they give you this equation. 2y plus 6 equals 2y plus 3. All right? So what do? The normal thing. Distribute. And you're left with 2y plus 6 equals, I'll write this in purple, 2y plus 6. So what happens here? Try to get the variables on one side, right? But what happens? I'm sure as most of you can see right now, when you subtract the 2y on both sides, cancel. I'm going to do it with a different color. And then you get this bizarre thing saying 6 is equal to 6. Now the question here is, when you see something like this, you ask, yourself, is this statement true, false? So again, I doubt that there's going to be a ton of these problems on the final. However, knowing them is super, super helpful. I'll tell you that right now. Okay. So what do you do when you did your math and then you look at the problem, you're like, holy crap, all my variables are gone. Did I do this right? You double check, you triple check. Maybe you get upset and you ask me for help and you're like, oh my God, I don't understand this. What the hell do I do? And I go, yeah, no problem. I'm more than happy to walk you through the process so that you can have hopefully an aha moment, a discovery moment, if you will. Okay. So then you kind of go, okay, well, what do I do? Where do I go from here, right? You ask yourself, is this a true or false statement? If it is true, this is what it makes it an identity. So true means the equation is an identity. Okay, so if you look back at the definition here, right, just to clear out some cobwebs, if you will, it says an equation that is true for any value of the variable is called an identity. Like, okay, what the hell does that mean? And then furthermore, it says the solution of an identity is all real numbers. So what does that mean? You do the problem, you ask yourself, is this true or false? In this case, it's true, and it's an identity. This means, in a nutshell, for any number in the world you can think of that you plug into y, this statement is always going to be true, or this equation is always going to be true. And you can test it out, right? If you go to the very top and you put in, say, a 0 for y, well, what happens? On the left-hand side, you get 0 times 2, which is 0, and it's 6. And then on the right-hand side, you have now, you can calculate inside the parentheses. So what's 0 plus 3? Well, 0 plus 3 is 3, and 3 times 2 is 6. Boom, done. And you're like, okay, that sounds like it was convenient. You just use an easy number, 0. Let's try a harder number. Say something wacky, like -1/2, right? So say you plugged in -1/2 for each y. And remember, since the variables are the same, you have to plug in the same number. You can't just plug in 0 for y and then -1/2 for the second one. No, they're both the same variable, so therefore they get the same value. So you get, what do you get? On the left-hand side, what's -1/2 times 2? -1/2 times 2 is -1. And -1 plus 6 is a -5. And then here, same thing, you get -1/2 plus 3. Well, what's 3 minus 1/2? That's 2.5. What's 2.5 times 2? 2.5 times 2, right? That's also 5. So that's what they mean by the solution for an identity or of an identity is all real numbers. That means no matter what the variable is, right? It can be any number you pick in the world. It's always going to give you a true statement. And then when we do the algebra and we arrive at this statement here of 6 equals 6, this is to show you that the equation is an identity. So that's that. Okay. Now, if it's false, which I didn't get to yet, that means it's a contradiction. What does that look like? It looks like, well, what we're going to do for example 6 here. So example 6, let me find a contradiction for you guys. Okay, this one's a little bit longer, but we can do it. So 5m plus 3, 9 plus 3m equals 2, 7m minus 1. So take a moment to write that down. All right, so let's do this problem. So as you can see, there's multiple distributions here. You can see this one. You can also see this one. I'm going to do both at the same time, but I'll color code. So 5m in front plus 27 plus 9m. This is equal to 14m minus 22. And then you combine terms that you could on the same side. So that's this one and this one. So that's 9 plus 5 is 14m, right? 14m. Get 27, that was a plus sign. And then we're left with 14m again minus 22. Now I'm going to scroll down a little bit and you can see that the 14m's are going to cancel. So those are gone, and we're left with 27 equals -22. So again, you ask yourself, is this a true statement? Hopefully, go, no, it's not. Actually, let me do a circle as well. Oh, that is not a circle. Right? This is not true. In other words, you draw the little slash here. So what do? You ask yourself, is this a true statement? And if it's false, contradiction. So that's what this is. When you look at it, same thing. An equation that is false for all values of the variable is called a contradiction. A contradiction has no solution. So in other words, what they're telling us is that no matter what number, any number in the world, any number that you plug in for, in this case, m, as in 0, -1, 1,000, 10, square root of 2, pi, right? There's no special number that will give you a solution that will make both sides of the equation equal. So I'll say that again, because it's a little bit harder to understand this time around. You got an equation in front of you. You simplify it. And what happens is that the result is a contradiction, or it's false, a false statement, because 27 does not equal -22. And that means no matter what number you pick to plug into m, or the variable in this case, it will never give you a balanced equation where the left side is equal to the right side. Never. And in mathematics, those type of statements are important, never or always, because you know that mathematics allows for those. You know, there isn't a scenario where it's like, oh, well, sometimes this happens or sometimes this doesn't happen. No, it doesn't work that way, right? So that's very important to know. Before I move on, what questions do we have here about the whole contradiction and blah, 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 this? All right, I have to do a little bit of paperwork right now. So it's 3:13 right now. Let's take a 5-minute break. No, we'll give it longer. We'll give it a 10-minute break and then we're gonna resume class, okay? So it's 1:13 right now. We're gonna resume back at 1:23, okay? So if you need to take a drink of water, grab some food, stuff like that, do that as I fill out this paperwork. Again, if just in case if your audio is disconnected, we're going to resume class at 1:23. Classify exact-based drivers as employees. Crap, I think I did this wrong. Damn it. All right, so let's start up again. So we just finished section 2.4, and then section 2.5 has to do with solving equations with fractions or decimals. But we've already done that though. So you see the problem with having the algebra and the pre-algebra textbook is that it's redundant sometimes, right? So we already did this. And even if you go through the problems and you're kind of going like, well, wait a second, this looks the same. It's because it is, right? And they go further by teaching you about how you can clear the fractions by multiplying by the denominator. And that's exactly what I taught you earlier, right? A little bit on Monday and more thoroughly today. So we're going to skip that. And you don't, this example looks interesting. So I lied. We're going to do one example here. Someone tell me, what would you do if you solved this problem? And then solve. Anybody have an idea here?
I don't know if this is right, but will we multiply x over 2 by something to make the denominator 4, if that makes sense?
Yep, exactly. You could do that. You could use what I described or taught earlier, where you multiply x over 2 by 4. But if you multiply by 4 on the right side, what do you also have to do? Multiply 4 on the
Left side?
left side. So this is exactly what I taught, right? It allows us to clear the fractions, and you can see that you can't multiply by 2, because if you multiply by 2 on the right side, 2 disappears. Multiply by 2 on the left side, the 4 doesn't disappear completely. So that's exactly like what I taught you. So this is like what I taught. Okay. The other option is that when you see a fraction equal to another fraction, what does that remind you of again, if anything? What do we do when we have two fractions equal to each other? What do we normally do there? When there's a variable involved? If it helps, think of the whole is over of equals percent over 100. What is that again? When you have two fractions equal, or two fractions and the equal sign between them?
Is it cross multiply?
Yes, exactly. Awesome, awesome. So you actually have two options when you look at an equation like this, because even though you can see here that this term is a little bit more complicated, it doesn't matter, right? This is still A over B equals C over D, which implies that A times D equals B times C. So if you did what I taught with the purple 4, right, you'll see that the left side cancels to 5x minus 3, and then it's equal to 2x. And then you just solve, right? Then you minus 2. No, actually, I'll do it this way. I'll subtract 5x, subtract 5x, and you're left with -3 equals -3x, and this implies x is equal to 1. Or can cross multiply, because you know that it is 2 fractions. Multiply. You notice that there are 2 fractions and they are equal to each other, right? It's not a simplification, it's not a reduction, it's not trying to put things in those terms. It's just regular. What that looks like is you would go on the left side, 5x minus 3 times 2, and then on the right side, 4x, and then you distribute, right? Oops, I didn't write that right. This way, distribute this way. So you got 10x minus 6 equals 4x. And if you subtract the 10x on both sides, lo and behold, you see -6 equals -6x. So therefore, x is still equal to a +1. So again, if you see something like this, just remember you still can use prior knowledge to solve these things. It's just a matter of what's easiest for you, right? So people that can understand the reduction of fractions easily, sure, you do it that way. People that want to use previous methods or prior knowledge so that it just seems easier because you recognize, then that's cool too. It's just a matter of personal preference and what you personally see when you, what do you call it? When you observe it, okay? So that's good. Thank you, whoever that was giving me the answers. Really appreciate it. And, excuse me, the decimals, again, you can use calculators for that. Now, there's 2 more sections here. Excuse me. I'm yawning right now. There's 2 more sections right now, and I'm going to do a brief example on both of them and then let you guys out early. But I definitely want to talk about them because this is what we're going to resume doing when we come next week. And then, again, there's no homework right now, no homework to do or anything because you got a midterm coming up, so you should be practicing stuff on the pre-algebra textbook. In terms of what you should be practicing, just all the sections. If you want, you can actually go to all the chapters and then do the chapter tests. And remember, the answers are in the back of the book as well. So that's one suggestion as well, okay? And linear inequalities. Okay, yeah, that's what I thought. All right, so section 2.6 is asking that, hey, you need to be able to rearrange variables. That's actually very important because this I definitely have on the line. So section, I'm gonna scroll up just a little bit so people can still have this if they're still copying. Section 2.6. Let me make sure I'm not overdoing it. We go all chapter sections on chapter 2, right? Yeah, we do. I don't know why they didn't show inequalities here. Okay. We'll have to probably save that for Monday. All right. So section 2 is they call it here, they call it solving for a specific variable. Oops, I spelled that wrong. Specific. Okay. Anybody remember the formula for, oh, I don't know, what is it called? is it called? Anybody remember any formulas for shapes, for example? Like a circle, square, rectangle, be anything like perimeter, area. I know those words, they buzz with you. Oh, come on, I know people remember. Or the formula for a triangle, when you find the area.
Isn't it a squared plus b squared equals c squared?
A squared plus b squared plus c squared. All right, perfect. So that is Pythagoras Theorem or Pythagorean Theorem. I always forget how to spell it. So let's use that as an example. I know it's a lot more harder than most people intended, but sorry. I just use the examples that you guys give me, so that's fine. But no, it's a good equation. So let me give you an example of that. All right, cool. So let's look up how do you spell Pythagorean theorem. Okay, so a squared plus b squared equals c squared. So if you saw this, you saw it in geometry. I'll tell you that right now. And this is again called Pythagorean theorem. All right, so say the question is, say this is example 8, and it asks us, solve the equation in terms A. Okay, so what do? The first thing to realize is that, remember, when you're given a question or a problem, like, you're not solving for numbers. So hopefully people realize that. And if everyone is already getting the idea of what I'm about to do, great. You can kind of half listen to me, half pay attention, and you can go from there. But the moral of the story is that you're supposed to be rearranging the formula so that you can isolate the equation that you want. Or in this case, the A equation, right? A equals whatever the heck A equals. So what do? You take the equation and you solve. And you just don't want to get thrown off by extra variables and everything like that. So if it helps, you circle, in my case, you square the variable in question. And then you try to get it by itself. So what is A squared doing to B squared? They're added. And you can see here, obviously, these terms don't combine. So what do? Pull out. Let me rewrite A squared again. So this is equal to C squared times C squared. So you can see it cancels, Nothing combines. They're different variables. Yeah, they both have squares, but there's nothing else you can do. Now, we didn't formally go over in this class, but how do you solve a square? Does anybody remember how to do that? You take the what? How do you get rid of a square? If you have 5 squared and it's equal to x, or the other way around, 25 equals x squared. How do you get rid of the x? I'm sorry, how do you get rid of the square?
You square root it
Yeah,
or
you take the
something.
square root. No, you're right. Square root, right? Take this on both sides. You go with x. This is like a baby example here. And the square root of 25 is 5. Or in other words, what two numbers multiply to 25? What two numbers are the same that multiply to 25? And it's 5, right? So you do the same thing here, right? The cancels with the square. I know everyone's seen this at one time. Maybe we just forgot it. But you can see this cancels with this. But same philosophy. If you do it on the left side, you must right side. So therefore, A is equal to, write it all in one color now, C squared minus B squared square root. Okay? So this is what they mean by solving for a specific variable within an equation. All right, someone give me another equation they remember, and then that'll be our last example for the day. Don't be shy. You can do it. I know you can.
It can make up an equation, or it could be of something that we already know. I'm
No,
kind
don't
of
make up an equation. No, don't make up an equation. Just think of an equation that you used in the past. Doesn't have to be a fancy one. Whoever gave Pythagorean Theorem. Don't feel like it's like, oh my God, I gotta give a, no. Just any equation that you remembered from your school days. Or maybe most of you are like, no, I've been trying to forget all the equations in the world. I don't want to do any of them. By the way. I'm just gonna take rule really quick. Oh, come on, nothing.
Why don't you put a question and we'll help you solve?
Oh, that's cute, right? All right, cool. I'll do that really quick. You do that one on your own. So, given I all squared equals A, solve R. So go ahead and do that one. And then once someone gives me the answer, just feel free to shout it out so I don't take up any more time. And then we'll be good to go. Is Devaney here? Madison, you're here, right?
Yeah, I'm here.
Okay, cool. And then I think I just got an email from Ileana saying, So Ileana is going to attend my other class. Sarah Huggins, are you here? I thought I saw your name. Sarah Huggins. No? No. Kara Malik, you made it to the class, right? Still no? Samantha, I saw your name, didn't I?
Yeah, I'm here.
Perfect. Is Madeline here? No. Okay. I didn't scroll through fast enough to see everyone's name, sorry. But I wanted to leave this here, not flip back and forth as people are looking for stuff. So your equation, whatever it is, right? It needs to end with r equals something. What is it? What's the something? I'll write it here real quick so that people can see. Pi r squared. That's area of a circle, by the way. That here for you as well. But thanks for everyone's participation. I know that it's been a while since we've gone all the way through for almost 2 hours. But remember, you're not going to be assigned homework just unless you really want to practice. You want to practice the chapter exams, right? That are at the end of every chapter, 1 through 7 in the pre-algebra textbook in preparation. And the nice thing about those is that there's a mix of problems for 1, and 2, the answer should be in the back of the book. And if they're not, you just email me and then you say, take a picture of your problem, go like, hey, I'm having trouble with this problem right here. And then you just do it. That's all.
I don't know if you saw, but someone asked what was the date for the term.
Oh, I didn't see, so thank you. Remember, because there's going to be communication on my end, it doesn't really matter when the date is, as late as that sounds, because what happens is that since it's going to be take home, what you're going to end up doing is I'm going to assign it, and depending on the day of when I assign it, like say if I sign it late tonight, for example, I'm not going to say it's going to be due a week from late tonight. That's unfair. I'm going to give you the full 7 days of when it's available for you. So it's supposed to be at the end of this week or the beginning of next week, like I said, but basically just keep an eye out for the announcement on Blackboard as well as the email that I'm going to send out to everyone. And you basically just have 7 days from when you see that to do it. So hopefully that explains it for everyone. And thank you for letting me know that that question was asked.
Professor,
Uh-huh.
would the answer to this be r equals pi plus a?
How about,
I mean negative pi plus a.
How about,
I'm just confused.
No, that's okay. So that pi, you need to move it away from that r squared, right? I hope everyone understands that. So these two guys are stuck together. When two variables are next to each other like that, what are they doing? What's that operation called?
Isn't it multiplying?
Yep. So what I was going to say, it's multiplying. So what's the opposite of multiplying?
Dividing.
Yeah, so you actually have to divide here. Don't subtract. So you divide by pi, and you divide by pi. So then the pi cancel. So then we're left with r squared equals a over pi. So that was close because you were saying, oh, I gotta get rid of it somehow. And it makes sense to think of negative because everything's positive here. You don't see any negative signs. Then you have to remember, oh, right, these variables, even though you may not know what they are, they're acting like numbers. So when you have two things next to each other, they're multiplying. So the opposite is dividing. And then now, last but not least, to get r squared to be r by itself, we take what again?
You square root it?
Yep. So then it's this, and then this implies r is equal to the square root of a over pi. So thank you again for participation. Remember, practice, please, the chapter sections in the pre-algebra textbook, 1 through 7, technically 2 through 7, but 1 if you want to look at it a little bit, okay? You're going to receive an email and the announcement of when I actually post it. The moment it posts, you have 7 days to do it, so don't worry. You're supposed to work on your own. And obviously it's open note / book because it's obviously take home. But I encourage you to do it the best you can on your own. And last but not least, you want to do it on paper and pencil because it's not going to be multiple choice. It's going to be open-ended so that I can see people's work and give you partial credit. And then there'll be more instructions on how to upload and all that fun stuff, okay? Let me back up this file so that you guys have it on Blackboard. So that's done, and then I'm gonna. What other questions do you have for